Morning, everyone. Can you all hear me in the back well? Awesome. So I'm really excited to be here. I'm really excited about what we're working on at NVIDIA. NVIDIA is known for making things faster, so speeding up applications. And I like to think that Python is one of the most usable languages. It allows people to really have great functionality. And one of the things I'm going to talk about is how these two things are coming together. But when I submitted this talk, I didn't know that Francois was going to be talking after me. And I'm sure he's going to have a much more articulate and amazing thing to say. So I'm going to be somewhat quick to get out of his way. I'm amazed that he's here and really excited to listen to him. So first I want to start with CUDA. And so NVIDIA is primarily known for its graphics, these wonderful renderings, video games, very large streaming platforms. But then there's also this language that we've developed over the years called CUDA. And CUDA has grown tremendously. It's used in most of HPC. The number of downloads of CUDA have just kind of skyrocketed across the years. And CUDA is the backbone of our acceleration. It allows us to write in a simple way parallel computing applications that allow us to use the hardware that we provide to accelerate many different types of things. And so more about some of the acceleration. Over time, we've accelerated more and more HPC apps. We went from graphics to high-performance computing, and then deep learning and so forth and so on. But we've always kind of stayed true to our core. And so we've accelerated more and more of the HPC ecosystem. And so things like GROMACS, Amber, Quantum Espresso, these applications are constantly getting improved and modified. And just from one year to the next, we see going from 25x to almost 40x on average in these applications. And that's because we can constantly tune our software and hardware to really allow people to get more performance. And the great thing about this is the high-level code doesn't change. This is all things that are happening at the CUDA C++ level, the CUDA Fortran level, and with our hardware that are giving people more performance. And we're also seeing this in deep learning. So if you go back to our Pascal generation, P100, to our V100s today, you're seeing a 25x improvement for training things like ResNet 50. And this is, for me, one of the most amazing things because the high-level code, again, hasn't changed. But this is a combination going from CUDA-8 to CUDA-10, going from FP32 down to using tensor cores. And so making things faster generation over generation just allows people to do more. There's more things that we want to study. There's more things we want to experiment with. And this iteration is really what allows us to get to better results. And so we see this both on the training side and deep learning, on the inference side. And this is really powered by our tensor cores in the voltage generation. And these tensor cores allow us to do this mixed precision, use FP16 and int8 when appropriate. And one of the things that we're doing, working with different frameworks, is to make that easier. So things like PyTorch and MLPerf, where we push down a lot of this mixed precision and automated it, so these frameworks could just run 2, 3x faster. And so this is kind of core NVIDIA, what most people know. Very computationally demanding applications, make them a lot faster, and make them faster year over year, better hardware, better software. And on the other side, there's Python. And so Python has just been growing tremendously over the years. There's many Python libraries that we all use. But just for simplicity, we're going to talk about pandas, NumPy, and scikit-learn. So data frames, arrays, and machine learning. And so these are kind of the backbone for data science. And what we see is people can pick these things up very quickly. And so people use these libraries, they start to experiment, they iterate, and the adoption is very apparent. Stack Overflow did a study last year where they were showing the number of questions, essentially, by language. And most languages are staying fairly constant or maybe even trending down, whereas Python is seeing a dramatic increase. And we see this survey after survey. No matter what the survey is, more and more people are using Python. And this is why I'm really happy to be here. Anaconda has just done a tremendous job of supporting the Python ecosystem. Numba, for instance, you write arbitrary, simple Python code, different types of loops, different types of things, and then it parallelizes this. And it optimizes it for CPU, power, GPU, to really gain all the performance and the flops, essentially, behind these different hardwares, while still exposing it in a very simple Pythonic way. And then we have Conda, the distribution that hardens these different libraries, that allows us to have these simple Conda installs. We have Conda Forge, which is really useful in the scientific community for people to build new Python packages and then to share them with other people. And then finally, Dask. Dask is a Python framework, a scheduler, essentially. It allows us to take Python jobs that were maybe designed for a single core or a single socket or a single unit of hardware, and then parallelize that across multiple of them and then multiple nodes. And so we use all of these things today in Rapids. We use Dask for scaling Rapids. We use Conda Forge currently for the distribution. We use Numba for UDFs, user-defined functions in our CUDA-X layer. And this is really important that we're building on this ecosystem. We really try not to reinvent the wheel. And so the Rapids project, which I spend most of my time thinking about and working on, one of the reasons why we've been able to move so fast is because of all of you. You said, hey, we like these APIs. There's been a lot of time invested in the ecosystem and the structure of it. And what we're trying to do is really just leverage the ecosystem to add GPU acceleration, something that NVIDIA has been very well known for. So a little bit more about Rapids. Rapids at its core is 3 libraries: CUDA-X, our data frame library; cuML, our machine learning library; and cuGraph, obviously our graph analytics library. And these are meant to parallel things like Pandas, scikit-learn, NetworkX, and GraphX. But we still want to make sure that the Pythonic API is the same across all of them. In addition to this, as I said earlier, we use Numba for user-friendly functions. We use Dask for scaling. And then we also use things like the CUDA array interface from Numba to connect to other deep learning frameworks, as well as DLPack to make it easier to connect to things like MXNet, Chainer, and PyTorch. And all of these things come together for CUDA-X. And so CUDA-X was announced a few weeks back at GTC. And CUDA-X is really kind of the amalgamation of all the different libraries that NVIDIA has been working on. And so NVIDIA has many open source libraries like Nickel and Dolly. We have things like cuBLAS, cuDNN, AMGX. And so we have a host of these libraries that are either in the CUDA toolkit or open source libraries that we've been developing. And they all bubble up to allow these higher level end user libraries like PyTorch and TensorFlow and MXNet to really be optimal. So users don't have to worry about all the CUDA acceleration under the hood. They can just use the simple Python APIs to really do what they want to do, which is discovery, scientific analysis, machine learning, and to solve hard problems. And what we love about CUDA-X is it's everywhere. So same as CUDA, where we had the whole CUDA everywhere mantra, whether it was desktop, data center, or cloud. CUDA-X is accelerating applications that are everywhere, whether these are ML services, whether these are different deployments, whether they're deep learning frameworks or machine learning frameworks. CUDA-X is really the backbone behind all of them on our NVIDIA GPUs. So how can you get started? We have the NVIDIA Data Science Workstation, 2 RTX 8000s or a single RTX 8000 or 6000. So think 96 gigabytes of GPU memory in a single machine, preloaded with different configurations, whether you're doing ML or DL. And it's pretty fast. And it will continue to get faster over the years. And this is one of the things that I love about NVIDIA. Things are fast now, and they continue to get faster. And so we have the workstations for people who just want to kind of have something next to them, plug it in and go. And then we also have CUDA-X in the cloud. So every major cloud has NVIDIA support, whether that's AWS, Google, Microsoft, and then many more. And so earlier on, I gave a talk yesterday with Keith where we were talking about how Kubeflow has adopted Rapids, GCP, Azure. And we're going to continue to add more and more cloud support, more native cloud support, not only for Rapids, but for all the other CUDA-X applications out there like TensorRT and the various deep learning frameworks. And for you data center folks, we have our scale out. And so these are the NVIDIA T4s, so 130 teraflops in a single machine with 4 of the T4s. So you can see the performance as well, 10 to 15x improvement depending on what the application is. And these are kind of your standard workhorse servers. So rack many of them and just kind of scale out to different applications. And then for some of the more computationally demanding problems, we have scale up as well. So this was kind of our initial benchmark from when we started. You could have hundreds of nodes doing traditional machine learning and data analytics, or you could have a single DGX2 crunching away and getting some pretty amazing acceleration, essentially about 50x comparing CPU to GPU. And so in conclusion, NVIDIA, we're a company we're an AI company. We're built around acceleration. We want to accelerate many applications that are useful to you all, whether it's computational biology or computational fluid dynamics or deep learning, data science. Things need to go faster. People want to iterate more. People want to get to learning more quickly. And this is how people get better results. And in essence, this is how we improve society. And with that, thank you.